Okay, the first thing you want to do is download the Google Science Journal app. You want to install that on at least one cell phone. Then you want to download Frequency Generator and put it on another cell phone. This is the one I use. They're all probably good, but this is the one I use. Next, you want to get a remote control car. I have one here that I can rest a cell phone on and drive it. Then you want to go into your Google Science Journal app and go to the pitch application and see if you can figure out the pitch of your remote control car. You can see there are a lot of sounds. The reason you want to know the pitch of your remote control car is if the pitch that you're going to eventually be listening to is too low, then your experiment won't work. I found out that with this car, as long as I had the pitch set to 1,000 hertz, everything worked fine. You'll understand what I'm talking about in a second. When I took the data from the phone that was hanging, that the car passed under, I looked at the graph and I found that while I was recording, when the car drove under, the maximum frequency was 1005.4 hertz. We can use that in the Doppler formula to calculate how fast the remote control car was going. So here we see the Doppler formula. This is the frequency of the detector. The hanging phone heard 105.4. Frequency of the sender, the phone that was on the car that was driving was sending out 1,000 hertz. The speed of sound in here in room temperature is 343 meters per second. The phone that was listening, or the detector, was just hanging from the chair, so that phone was not moving, so that's a 0. And then this is what we're looking for, the velocity of the sender, or in other words, the velocity of the RC car. And when you work the whole formula out, you end up with 1.8 meters per second as the velocity of the car, and that is the velocity of our RC car. So it works.